Welcome to another video. Today we've got common factors we're going to talk about. And I've written out a couple of numeric examples. Oftentimes I find that people can understand the algebra a little bit better if they've played with the numbers a bit. Remembering that algebra, when we're using algebra, the letters are just standing in for a number that we don't know. And so anything we do with the numbers should work just fine with the algebra. And we're just going to start off with something really simple. So 8 plus 6, hopefully everyone sees that's just 14. Now, what we could do, though, is we could think about going backwards and just trying to think about some way that we've created this problem. So this is the problem, and we're looking for the question. Okay? This is almost like the answer, right? We're going to go backwards. And so to do that, we're just going to think of a number that divides evenly into both of these. And so it looks like the biggest number we could come up with would be 2. And so now I want to know what numbers would we need to multiply by to get back the original set of numbers. So 2 times something will give me 8. So 2 times 4 gives me 8. And 2 times something would get me 6. Well, 2 times 3 gives me 6. And now we'll just use that BEDMAS that we're always talking about, just to run a little check to make sure that this still works. So on the right-hand side there, we know the left-hand side is equal to 14. So on the right-hand side, we've got 2 times 4 plus 3, which is equal to 2 times 7, which is 14. So checks out. So it works. So what we did was we looked for the greatest common factor. So that is the greatest common factor. Greatest common factor. And then we use that to try to create an expression that when you multiply the greatest common factor back into that expression, you get back the original expression. And so now we're going to look at a different one. It's a little bit more complicated. We've got 72 and 12. And so I'm just going to start off by reminding you 72 is equal to 9 times 8. And 12 is equal to 4 times 3. And so I'm going to write that over here. So 9 times 8 plus, I'm going to reorder that a little bit, 3 times 4. That's equal to the same thing as 72 plus 12. And again, I'm just going to keep kind of writing this in different ways as we go. So instead of writing 9, I'm going to write 3 squared. And I'm going to multiply that by 2 cubed, which is the same as 8. I'm going to multiply that by, add 3 times 2 squared in this case. And so now I'm looking for what things can I take out of each of these which they share in common. So in this case, I only have 1 3 they share in common. This term over here has 2 3's. This one only has 1. So we're going to factor out just one of those 3's. And then we take a look and we can see 2 2's here and 3 2's here. So they only share 2 of them in common. Now what would we have to multiply this greatest common factor by to get back the original expression? Well, in this case, I've got a 3 I need to add. I only had 1 3. Now 3 times 3 gives me back the 3 squared up here. 2 squared times what gives me 2 cubed? Well, just 2. 2 squared times 2 gives me 2 cubed. Now if we look at the second term, 3 times what gives me 3? Well, just 3 times 1 gives me 3. So looking at the second part, 2 squared times what gives me 2 squared? Just 1 again. So this whole thing times 1 will give me back that expression there. Okay, so what this taught us is that we can kind of treat each of the factors or each base separate from each other. And so if we go to a more complicated example, that should guide us in order to figuring out what to do. So let's just deal with the numbers first, because that just showed us that we can deal with everything individually. So what do they share in common, or what's the greatest common multiple between the two? Or the greatest common factor? Well, looks like it's 2. 2 divides evenly into 4. 2 divides evenly into 2. That makes 2 the greatest common factor. Okay, it's the biggest thing that does that. Now let's look at the x's. Well, this one has 1x, and this one has 2x squared. So only one of those x's is in common between the two. This has 3y's, and this has 4y's. So again, only 3 of them are shared in common. Now we're just going to ask ourselves, what would we need to multiply this factor by to get back the original term? So to get the original number, or coefficient, we just need to multiply by 1, so we're not going to worry about that one. To get back x squared, we need to multiply the x here by another x. And to get back y to the 3, we would need to multiply by 1 because we already have y to the 3. And we don't normally write that 1, so we'll leave it off. Now what do we need to multiply by to get this second term? Well, 2 times 2 gives me 4. X times 1 will give me back the x, so we don't write that because we don't write the 1. And then y to the 3 times y gives me back y to the 4. And so there, we've factored this. This is fully factored. What's inside the bracket? There's nothing in common between the two, so that gives us a hint that we did the right thing. Okay, now this one's pretty tough because when you look at it, these terms don't share something in common between all of them. These two have x's, the first two have x's, but the last two don't. The first one, the third term, and the fourth term all have y's, but the second term doesn't. The second and the last term have w's, but the first and the third terms don't. So that leaves us in a bit of a spot. There are no common factors between all terms. Okay, so when you run into that spot, try doing it in just pieces. And hopefully you end up with something a little bit more constructive. So in the first set, they both have an x. So I'm going to factor out the x. So what would I need to multiply the x by to get back xy? Well, I'd need to multiply by y. What would I need to multiply the x by? In order to get xw, I'd have to multiply by w. Likewise here, I'm going to take out a y. What would I need to multiply y by to get y squared? Y. What would I need to multiply y by to get yw? A w. Okay, now you might be thinking to yourself, how does this help us? Well, look now. This here, for both of them, this whole thing, are something that the two share in common. So we can take that out. Y plus w. Now what do you need to multiply y plus w by in order to get x y plus w? Well, just x. What would we need to multiply it by to get y plus w? Well, just y. This process here, where we have smaller groups that we're common factoring out of, is called factoring by grouping. And it's a form of factoring. Okay, so it's important you know the terminology. You could be asked, factor the following by grouping. Go take a look at one more. We're going to see a lot of trinomials. Okay? We're going to see a lot of trinomials because remember that this is quadratic. When you graph it, you get a parabola. And so later on, we're going to be doing this with expressions that actually represent something in real life. And so this is an important type of expression that you're going to see. So when we look at this, one thing that we notice is that all these numbers are divisible by 7. So that means we can common factor out of 7. You're left with x squared plus 4x minus 7. And then you look at this and you say, okay, there's no more common factors. Now there is a way of factoring that, but you can't use common factoring. And so that's up